Hello everyone. So next we are going to see about system level operating virtualization. It allows multiple operating systems to run on a single physical machine by abstracting the hardware. So in global market value about $8.78 billion dollars in 2024 with growth driven by cloud computing and data centers alone. A single Dell Power Edge server can host 50 plus VMs each running Windows, Linux or another OS. So what is system level virtualization? So it abstracts the physical hardware like the CPU, memory, storage and network. Create virtual machines, VMs with isolated environments. Each VM behaves like a dedicated server with its own OS and applications. So different some containers share the host OS kernel while VMs run full guest operating systems. Example running Linux, Ubuntu, Windows Server and Red Hat on the same physical server simultaneously using VMware ESXi. So the main components are hypervisor. So hypervisor is a software that manages the VMs. Example VMware ESXi in enterprise data centers, virtual box for personal use. Virtual machine. Each guest OS runs independently. Example, a developer can run both Windows 11 and Ubuntu Linux on the same laptop. Virtual hardware. So virtual CPU, RAM and storage network interfaces are assigned to each VM. Guest OS, the installed operating system like Windows, Linux or Mac OS. Types of hypervisor. So first one is the bare metal type. So it runs directly on hardware without a host OS and optimized for data centers. Examples include VMware, ESXi, Microsoft Hyper-V, Citrix, Zen Server. So main use cases are Amazon AWS EC2 uses the bare metal hypervisor for performance. So type 2 is the hosted. So it runs on top of an existing operating system. So easier to install and use, suitable for personal use and testing. Example includes VirtualBox VMware Workstation. So main use cases are students running Ubuntu inside Windows for lab experiments. Benefits of virtualization are resource efficiency. It increases hardware utilization from 5 to 15% to 80%. Example, a company reduces 100 physical servers to 10 virtualized hosts. Cost reduction up to 70% savings in hardware, power and cooling. Example, Infosys saved millions by consolidating servers into VMware clusters. Isolation and security. So each VM is isolated, reducing the risk. Example, if one VM is infected with malware, others remain unaffected. Portability. So VMs can migrate between hosts. For example, VMware vMotion enables live migration with no downtime. And in terms of disaster recovery, snapshots and replication ensure a rapid recovery. Example, banks can replicate VM images across data centers for 24/7 uptime. Key use cases. So cloud computing, for example, AWS EC2, Microsoft Azure VMs, Google Cloud Compute, all use hypervisors. Data center consolidation. Physical to virtual P2V reduces space, power and cooling. Ratio 10 physical servers, 1 hypervisor host. Development and testing. Developers run multiple environments without separate hardware. Example, testing apps on Windows, Linux and Mac OS simultaneously. Virtual desktop infrastructure or VDI. So employees log into virtual desktops and stored in the servers. Example, Citrix virtual desktop for remote employees. So the main challenges and considerations are performance overhead. So hypervisor introduced 5 to 15% resource loss. Example, gaming VMs perform slower compared to bare metal PCs. Management complexity. So requires tools like VMware, vCenter and skilled staff. Licensing costs, Microsoft charges per core licensing for Windows Server VMs. So noisy neighbor effect. So one VM consuming excessive CPU or memory affects the others. Hypervisor security risk. So a hypervisor attack VM skip can compromise all the VM types. Example, VNOM vulnerability allowed VM breakout from QEM. So in a conclusion, foundation of modern IT. So indispensable technology, hypervisor form the backbone of modern cloud computing. So agility and efficiency. Virtualization enables scaling and resource optimization. In continuous evolution, hybrid cloud and containers like Docker, Kubernetes now complement virtualization. So enterprise core powers all major cloud providers like AWS, Azure, GCP and enterprise data centers. So in a summary, system level operating virtualization enables multiple OS environments on one hardware platform. through hypervisors. It delivers efficiency, security, and scalability, forming the foundation of cloud enterprise IT and data centers through challenges like cost, performance, and security must be managed carefully.